All right, so we're going to look at a volume problem and talk about what that looks like whenever we go to answer it. So we have the volume of a box given by this function. X represents the length of the box in inches, and you would need to find all values of X for which this model makes sense. So when you're trying to talk about, well, what makes sense when it comes to volume? Well, volume has to be positive. So I'm interested where that curve is positive. So I want to know, when is it above 0? Notice 0 is not positive or negative. So I want strictly above 0. 0 is not included as a volume. So if you look at this graph, there's two intervals where this happens. Here's the first one, and here's the second one. So once again, I would go ahead and label them interval A and interval B. So I can see the answer for interval A. X values that are between 0 and 3 will generate a positive volume. What I can't tell is where interval B begins. I can't see where that x-intercept is. I know it's a little after 6, but I'm really not sure decimal-wise what that is. So that's what we need to figure out. So I just want to make a couple things aware to you guys that, okay, the part that's shaded would be above 0. That's within interval A and interval B. We're not going to reject interval A this time because these are positive X values and you can have positive length. So it's not going to be like the roller coaster problem where you can just say, oh, we're going to reject interval A. Interval A makes sense in this picture. We also need to know that volume of a box is length times width times height. So when it comes to volume problems or box problems, we definitely want to factor that because we're going to factor it into 3 sets of parentheses. Each parenthesis represents a dimension. We also want to note that 0 and 3 are x-intercepts, and we can use that to help us factor this polynomial. So step 1, just like any polynomial, is factor out a GCF, and I do see a GCF of x. So the first thing I would do is factor out an x, and then I need to factor this remaining quadratic. Again, you could draw an x and use the x method with grouping for factoring, but that's not going to be as fast as synthetic division. So I'm going to take my 2, my negative 19, and my 39. When you do synthetic division, you can't use a 0 because you can't technically divide by 0, but you can use the 3. So we're going to use 3 in our synthetic division and get our remainder of 0. So I want to convert my answer from synthetic into factored format. I have my GCF. My divisor is x minus 3. And my quotient is 2x minus 13. So it didn't take very long to factor that polynomial if you went with synthetic division. So what you want to remember, though, is that the length right here, technically that is in parentheses. So your GCF does have parentheses around it. We're just not required to write them. So you can see there's 3 dimensions and there's 3 letters, right? So 3 dimensions, 3 factors, 3 letters, they all correlate. So they told you the length is x. They said that in the directions. X minus 3, we'll just call that the width, and we'll call 2x minus 13 the height. If you switch these around, it's not going to change the answer. You wouldn't lose any points. All right, there's no way to tell which one's the width and which one's the height. It doesn't matter. They all get multiplied together to get the volume. So you can call them what you want. But you just need to see, okay, these are my 3 dimensions. So the x values that will generate positive volume, so the x values of these intervals would be 0, 3, and not 6, 6.5. If we set this equal to 0, we get our last x-intercept, which is 6.5. So any x values between 0 and 3 have positive y values, which means positive volume. Any x values after 6.5 also have positive y values. So those are the intervals where you get a positive volume. Now it's important to notice I did not include 6.5, 3, or 0. That would be wrong to do that because, for example, at 3, the volume is 0. We can't have a volume of 0. There's no box whose volume is 0. At 6.5, exactly 6.5, we have a volume of 0. So we do not include 6.5, 3, or 0 as answers. It has to be strictly above 6.5 and strictly between 0 and 3. So normally we'd circle that and say, there, that's our answer. That's where the volume is positive. That's what makes sense. Here's where factoring helps us not make a silly but crucial mistake. If you pick a test point in the first interval, say 1, well, 1 is between 0 and 3, right? So at 1, looks like the volume is about 20, right? That's realistic. However, if x is 1, you need to check that with your dimensions. It says right here, x minus 3 is the width. So if you let x be 1, your width is -2, and your height is -11. So even though they multiply to get you a positive volume, the only way that's happening is if two of the dimensions are negative. That's not possible. So we are going to reject interval A, not because it doesn't make sense on the graph, but because it doesn't make sense with the dimensions. So we're going to go with x is greater than 6.5. And you can pick a test point in that region, like 10. 10 works for all of these. You get all positive dimensions. So with volume problems, not only do you have to check where it's positive volume, but when you get those regions, you have to make sure that all of your dimensions are positive as well. And if you don't factor the problem, you're not going to know the dimensions that you need to check. So that's why I always tell my students with volume problems, you want to factor. So we're not going to use the quadratic formula for this because that doesn't really help us factor. We're going to use synthetic division or the X method. That will help us factor. Our next word problem is going to be easier, in my opinion, than the volume problem. This one's pretty straightforward. We have a profit function based on how many t-shirts we sell. So X is the t-shirts, P is the profit. It's important to notice it's in millions. So if I say X is 4, I mean 4 million t-shirts. So they're like, currently, if you produce 4 million t-shirts, you make $4 million. They want to know what other number of t-shirts could you make, but still make $4 million. So really, they're asking you to solve this equation. They're asking for what value of X will you get 4? Well, they already told you, hey, if you plug 4 in, you get 4 out. 4 million t-shirts makes $4 million. So you know that that's already a point that's on the function. So in other words, if you put 4 in for X, you get 4 for Y. They're telling you there's another number you can plug in for X and still get 4 for Y. There might be 2 more numbers that you can plug in. So what you need to realize is, well, if I subtracted this 4 to this side, so now it's set equal to 0, I could go ahead and say 4 is a 0 of this polynomial. So I'm basically taking all the 4's out and putting X back in their spot. But you know that if you plug 4 in for X into that formula, you will get 0 as an outcome. So this is the equation of my polynomial. But because I know 4 is a 0, I can use synthetic division. I want to point out that if you were to try to group this, in this case, grouping actually does work. So you could actually use grouping to factor this. But grouping doesn't always work, as you know. So I want to show you, well, what other approach could you take to factor this? So we're going to write our coefficients down. we're going to divide by our x-intercept, or R0, and you should get a remainder of 0. And then I'm going to convert that into factored form. So the 4 becomes x minus 4. If we started with a cubic, our answer or quotient begins as a quadratic. So this is negative 1x squared plus 0x plus 1. Now this is a difference of squares. It's the same thing as saying 1 minus x squared. So I like to think of it like this. That makes more sense to me. So if you're going to factor a difference of squares, it's going to be 1 minus x and 1 plus x. And you want to bring down your x minus 4. So I'm still factoring the polynomial so I can find all the x-intercepts, because that's what's going to be the answer to my problem. So I already knew that 4 was an x-intercept. I now know that 1 is an x-intercept and negative 1 is an x-intercept. But we want to reject the negative 1 because you can't produce negative 1 million t-shirts. So they're telling you if you plug 1 in for x, you are going to get 4 million. So the final answer is 1 million t-shirts. So in my next video, we'll turn it back to the volume problem because that's the one that's the trickiest. So we're going to do one more example of a volume problem and then see how that goes.